Hello guys, hope you all are doing well. So in today's video we are gonna look at Opencv library. It's the most famous library for image manipulation. We will talk about Opencv and how it makes image manipulation a lot easier in further videos. But this video will only cover the basic image manipulation strategies like changing the channel of the image, applying filters on top of the image. Now let's look at the content which we are gonna cover in this video. We are gonna cover some basic manipulation techniques like how do we read and write an image using OpenCV. Then how do we convert the channel of an image? By channel I mean if a image is having 3 channel RGB, how do we convert that to a gray channel image? In layman terms, how do we convert a color image to a black and white image? Also, how do we resize the image? And at last we will look at how do we apply different filters on top of the image. Filters will be a little bit advanced concept, so I would suggest you to have some in-depth knowledge of Python as well before moving forward in this video. So before further ado, let's jump into our coding part. To save time, I have already created a skeleton of OpenCV program. So let's move forward with our programs. First of all, you need to install OpenCV. If you don't have OpenCV already installed in your system, you can go to the OpenCV library, or you can go to Python pages. Here it is. Yeah, here it is. Pip install OpenCV Python. You can just copy and paste it in your window, and you will have to just run it, and it will install OpenCV for you. Be aware that if you install OpenCV, you might need to restart your kernel as well. So keep tab on your warnings as well. It will tell you by default that you will have to start your kernel. So once you restart your kernel after starting the installing the OpenCV, we will import all the necessary libraries required for our program. First of all, we are going to need NumPy. Then we are going to need OpenCV. Of course, OpenCV is the soul of all of this project, so definitely we need that. Then to display the images, we will need matplotlib library. We can display images using multiple ways. I'm using matplotlib here specifically because we will be able to display inline images with matplot. So let's move forward. Let's try to read image from my local system. I have already image name at batman.png in my local system. Let's see what that image is. So I have this image in my local system, Batman having a nice vacation. Let's try to read it through my Python code using OpenCV. To read the same image, OpenCV provides cv.imageRead function. So inside this, we'll have to supply the path of the image from your local system. Here I am supplying the same path where it is stored in my system, and I'm trying to read it. I will just run the cell, and the read image is stored inside sample img variable. Display the image. OpenCV provides imsSo function to display the image. We will just have to pass the variable where the image read has been stored along with the protocols of witk and destroy all windows. The moment you run the cell, it will create a separate window and it will display the image for you. So but the problem you see here, it has created a separate window for you. That's why we will use further onwards matplotlib. So in this function which I have created, display image, you'll just have to pass the path of the image and it will display the image for you. Let's run it and see the output, how easy it is. Voila. So you see here, earlier we will have to go to a separate window to see the image. Now it's been displayed in inline. That's why I'm using matplotlib to display images here. Now since we have displayed the image, at least we achieved our first step, which is reading the image. Now what if I want to change the channel of the image? By changing the channel of the image, what I mean, let's try to change this colored image to a black and white image or a gray image. So in technical terms, we call it changing the channel of the image, to be more precise. Now to change this channel, OpenCV provides a CVT color function with the image which we are gonna change, and this is how we are gonna change. The red image is in BGR format, so we will supply BGR to gray. This is a default code which you can find on OpenCV website. So every channel you need to do conversion, there is a particular code to it, and you have to be very specific on what channel conversion you are trying to do. Here what we are trying to do, we are trying to do a BGR conversion to a gray channel conversion. That's the moment we run it, it will be stored inside variable name gray image, and inside this function cv.imageWrite, I'm trying to write the same gray image into my local system, and the same stored image I'm trying to display here using the display image function which I have written here. So let's do it one by one. Let's first just convert the image to gray channel. Now our image has been converted into gray channel. Now let's write the image. cv.image_write will write the image into the local system, and the path, whichever path we provide here, it will write at the same place. And what image we have to write, this is the variable name, that's what here. So let's write the image. Okay, by default it will return true or false. If it returns true, that means image has been written to your supplied path. Let's go and see whether it has written or not. So this is grayscale. Okay, there it is. Voila, we have a black and white image of Batman enjoying his sun. It doesn't always make sense to go back and see whether image has written or not on our local system. So let's try to display it here as well. So let's run all the cell at once. Okay, so we have one issue here. The image which we wrote was a grayscale image, but when we try to read it and display it, it's showing some sort of different image altogether. The problem is that when we are using matplotlib to display image, we'll have to supply cmap for it. For example, to display same image, I will supply the path of the image, and inside plotlib we will supply what is the cmap of the image. So here the cmap of the image is gray, so I will supply it as gray and we will run it once again. See, the same image we are reading here, it's displaying as a black and white proper image, but here it's displaying as a, it's definitely a problematic image. It's not reliable. So to make it more precise, we supply the cmap of the image. Although in our system it's been stored as a gray channel image, the problem occurs because by default the way it works, like it reads the image as a bgr format, so you will have to supply the cmap. Now we have read the image, we have written the image, and we have displayed the image as well using two methods, opencv and matplotlib both. We have displayed inline image and image in a separate window as well. Now let's try to resize the image. There are many use cases where you need to resize the image in a particular format. So let's first read the image. So for reading the image, we will use same image read function and we will supply the path here. Now since we have read the image, let's try to print the shape of the image. Shape of the image is nothing but what is the width, what is the height, and what is the channel of the image. Here the channel is 3. It's the same image batman.png which we have used earlier. So it's the width, height, and the channel as well. So here it has channel 3. So sometimes images have channel 4. It's nothing to worry because it's RGB A channel will be there. So A is the alpha channel. Some modern mobile devices, they add an extra channel as alpha channel. So that will be RGBA. So that's nothing to worry. OpenCV can handle it perfectly. So here we have the image in format of 944 cross 1068 cross 3. Now let's try to resize it to a format of 150 cross 150 image. There can be a possibility where you have to supply a particular set of images to your machine learning model where you need to have that image in a particular sort of format. So in this case, I'm trying to resize the image into 150 cross 150. You'll have to supply the dimension like this. I mean, you can also supply it as a separate variable, but this is like more of a standard way to do it. To resize the image from OpenCV, we have resize function, and as a parameters we will supply which image to be resized, what is the dimension, and again interpolation. So inside interpolation we will supply cv.interarea. Again, if I have to explain interpolation, how do we supply it, and more theoretical concepts of it, it will go beyond the scope of this video. So let's just try to maintain it as a protocol that will supply whenever we're trying to resize an image, we will supply as cv.interarea. And once we resized it, we will try to write the same image using cv.image_write into our local system. So let's do it all at once. We can run all the cell at once, and the moment it returns true, that means you have resized the image and you have, I mean, written the image to your local system. Now let's try to read the image. Now we have already a function called display image to display whatever the path we will supply, and it will display it. Let's utilize that function and supply the path. So this is the path where we have written our resized image. Now let's try to see. Okay, now you see our image has been resized. Now how do you confirm whether it has been resized or not? Now if you see these pointers here, 0 to 140 and here again 0 to 140, this is nothing but a dimension of a proper image. So here our image is width is 150 and height is 150 as well. So earlier when we were dealing with this image, its height was around, if you see, it was around 900 and width was around 1200 or 1100. So what was the weight? Let's see. Okay, it was around 1068, so let's just round it. So this is how you can resize the image and you can display the image as well. Again, there is a bonus fact. If you don't want this ugly scale to come on side of your image, you can switch it off by using the function. Where is the function? Yeah, you can just do plot that axis off and it will switch off all the ugly scale around your image, and you can just call your function, and you see in this image there is no scale. So this is how you can switch on and switch off your scale as well. Now let's try to apply filters on top of the image. If you will have to understand filters and how they really work, you can understand it like that. If you have a certain image and you will have to denoise it, or you have to add certain kind of noise in it, filters will come into the place. In a more precise manner, suppose you want to blur an image. So to blur an image, you will have to filter on top of the image. In that case, we have two possible approaches in front of us, which is Gaussian blur and median blur. So let's first try our Gaussian blur approach. First of all, we will read the image again. We will be using same Batman image, and to apply Gaussian blur, we first need to identify what type of kernel we want on top of our image. For example, suppose we want to supply a 5 cross 5 kernel. Kernel is nothing but, you can understand it like that, a 5 cross 5 matrix. Okay. Again, on that kernel, we will supply inside our Gaussian blur. This is the kernel and this is the sample image I want to blur. So let's run this cell and display the image. Okay, so you see, do you feel any difference between this image and earlier image? Let's try to display both and we'll see the result. Okay, so this is the original image and this is the image after Gaussian blur. The difference is not very significant here. Now let's increase the kernel size. So if I increase the kernel size to 25 cross 25, and okay, so this is, you see clearly the difference here. The image is blurred a lot. So in actual scenario, we will have to choose this kernel really carefully. It will vary on our use case and depending on image as well. Similarly, we have median blur as well. So in median blur, you just have to supply on what image you will have to do median blur, and what are the nearest pixel you want to consider for averaging it out. So I will be considered 15 pixels, and I will be doing median blur on my sample image, the same image which I have read here. So let's do median blur on top of it and display. Okay, here it is. Again, if you'll have to understand in what particular scenario this will be really helpful, you can have a look at this image. Suppose we have this noised image. This is an original image taken from Opencv website. This is an original image, and after applying blur, median blur on top of it, this is what the output is. This type of filters are really useful when you are trying to do canny edge detection and other highly manipulative operations on top of the image. So if you want one more video on canny edge detection, you can hit me in comment and I will create a separate video for canny edge detection. This is pretty much a high level concept if you want to deal with canny edge as well. So for this video, this is what it is, and I hope you really liked it. Till next video, bye bye.